Well. So I know lab today was sort of confusing, so I wanted to record this video in order to give you guys a full and complete demo of what that lab assignment that we completed today in class was supposed to look like. I know we ran into some technical issues with CLion and the tool chain and things like that, but hopefully this will help. Before we get started, I just want to make sure that everyone has CLion and the toolchain, CMake, GCC, anything that allows them to run C++ on their machine, so Mac or PC. You need to have that already installed and ready to go before I can show you the rest of this. So make sure that you have those two prerequisites done. Now, having said that, let's begin. So the first thing we wanted you to do was to go to a GitHub Classroom link. And so this is the one that I threw in the Slack at the beginning of the lab today. So this is an invitation to a GitHub Classroom assignment. And as you can see, this assignment is one that I have already accepted. So it says you have accepted. Otherwise, it'll give you a button that says accept this assignment. You can just click on that and it will create your assignment repository, which is essentially github.com/SMU-CSE2341/ the name of the assignment dash and then your username. So the Liberrhythm is my GitHub username. So just yours should be whatever your username is. Now, it will allow you to go to your repository. And this is the GitHub web interface. You can see that there is this input file, the main.cpp file, a README. So a README is essentially a document that any good developer will create and write in order so that other people who look at their code can understand how to run it and what this code actually does. So it's a form of documentation. The CMake list.txt we'll talk about later. It just has some settings that you can configure for C++. And the GitHub/workflows folder has this build.yaml file, which will allow us to use GitHub Actions in order to get your code running on our end. Now, the first thing you're going to do is, this is all in the cloud. It's like on the web, right? So that's how you access it. We want to get a copy of this repository on your local development machine. So what you want to do is you want to go to clone or download. You're going to copy this URL, and then you're going to go open a terminal instance. So here I have this terminal. I believe on Windows it's called command prompt. And so here, I'm just going to show you what you're going to do is you're going to go to your home directory. So it's going to be the tilde represents your home directory. And then, for example, you're going to make a folder that says, so you do mkdir, which stands for make directory. You can say, okay, this is data structures projects. And that's the name of your, like a folder. This is just some arbitrary folder that you're going to create. Right? And so makedir makes that folder, and what you can do is you can cd, which means move into that folder. So data structures projects, you can do tab for autocomplete, and then you can click that, and now you can see that you're in the data structures projects folder. Now after that, what you can do is you can do ls, which shows you all the contents of that folder. Since you just created it, there's nothing in that folder. Now we're going to change that by doing our first git command, which is git clone. So we're going to do git clone, which basically copies your repository onto your local machine. And you're going to control V or command V that URL that we just copied, paste that there, git clone that URL, and then press enter. So you can tell that there's all this stuff that it spits out, but here it says unpacking objects 100%, 10 out of 10 done. That means it has succeeded. So if you get any other issues, just or errors, just Google them. Like Git is very well documented online and on Stack Overflow. I'm 100% sure someone will have had your issue. So now if you do ls, you can tell that there is this repository, week 1 lab Liberrhythm, and you can cd or move into it. And you can see that we have this CMake list.txt, the README file, the input file, and the main.cpp we had when we were looking at the web interface. So what's a little bit different about this is there's the .github and .git folders that were here. And so .github/workflows folder here. Terminal and Finder on Mac at least, so I'm working on a Mac by the way, will typically hide hidden files. They will not show the hidden files unless you specifically specify that, and then you can just Google a way to get those hidden files to show up. All right, so what we want to do now is we have this repository cloned down. And what we want to do is we want to open CLion and open the project in CLion so that we can develop with it. So here you can see that I already have, like I opened it previously, but I just cloned down a fresh copy of it, so I'm going to go find it. So I have data structures projects. I'm going to click into it. I'm going to click the project, and then I'm going to click open. So CLion is now loading all of these components and preparing the workspace and everything. And now you can see this README. So it automatically opens the README, so you can see all of these lab assignment stuff that you have to do. And yeah, so I'm not going to do this part, which is like the scenario for the assignment that opened the file and contains integers. I'm not going to write any code, but I'll write like some very basic code, like a cout statement or something like that, so that you can see how it works. But anyways, so if you open this tab right here, which is your projects, so there's a lot of other stuff. You can see that this is your project, but there's also external libraries, scratches, and consoles. You don't really need that for now because we're not importing any external libraries. So you can click on project files, and that restricts what is in this window pane to just the project. So yes, so you can see, if you're not seeing .github and .idea and .gitignore and stuff like that, just look up how to show hidden files in CLion. So besides the README, we want to look at the code, right? So you have this main.cpp code, right? And so if we walk through this, this is a main method. It prints out welcome to lab 1. It has an if stream and an OF stream, and then an integer right here. So argv1 is your first user-provided command line argument. So argv0 is always the build path, so don't worry about that, but never really use argv0 unless you are doing something with a build path, like printing it out or something like that. So what this program does is it reads the file specified by argv1, and it prints out all of the integers inside it, and then, so all the integers inside it, and then it also, at the same time, like here it prints it out to the terminal, but this is printing all of those numbers out to an output file. And so this is what this while loop does, and then it closes f in, closes f out, returns 0. All right, so what we want to do is I'm just going to show you, this is the build like kind of hammer symbol. This is basically compiling the project, seeing if there are like compile time errors. And so once you click build, this will actually do a bunch of stuff like kind of under the hood. It's all C++ stuff. It builds like a target and things like that. And actually when you build it, you will get what's called a build directory. And this will be kind of alongside your project directory. All right, so where I can show you this is you can see this folder suddenly came up. It's cmake build debug, and it's all of this stuff that cmake generated, including an executable, a copy of the source file, the input file, all of this stuff here. It's necessary for C++ to be able to run your program. Another way you can see this is we can go into the Finder. We can go into your home directory or wherever you saved that project. So for me, it's in data structures projects, week 1 lab, Libarhythm, and you can see it over here as well. So yeah. Okay. So once we've done that, the next thing we want to do is run. All right, so I had a couple of people in class today tell me that they could not see like this, either the build button or the run button or both was grayed out. And that's typically because you don't have a configuration set up yet. And that's usually because you did not have you didn't download the toolchain correctly or configure your system so that it could run and compile C++ properly. So this should be pretty much automatically done for you if you've done all the setup correctly. With Mac OS, you're going to have to do either git Xcode, which includes GCC, or download GCC and install that. I believe with Windows, you can do Cygwin or WSL. So just look at Doctor's Font Knows instructions for that, or ask a TA if you're having issues. So that's why that was a prerequisite to all of this. So basically I've built it and now I can run it. So if I run this, down in this kind of terminal area, you can see that it prints out welcome to lab 1 of CS2341, but it does not print out this. And this is because it's probably just not able to access the input file that is right here. So this is where I'm going to show you the input-output kind of things that you need to be aware of when you're using CLion, C++, and for GitHub Actions. So the first place is for cmakelist.txt. This will be in every repository and assignment you have. I think we're just going to include it for you. So here you can see that it says students edit the items below. This is something that we've written. So essentially, if I have another, say I have another text file. So we already did the input01.txt for you, but we could do input02.txt if that existed, right? And then it says the CMake project needs to be reloaded, and then you reload the changes. Since we don't have that, I'm just going to delete that back. But anytime you add something there, you're going to have to reload the CMake project. But yeah, this is a good example of what it's going to look like for your first project. So this is for C++. The next one, I would like you to open .github. It's workflows. You can go to build.yaml. So the part here that you need to look at is input files and output files here. So you're just going to list them. They're going to be separated by a space. Sorry, yeah. So if it was input01.txt, input02.txt, something here. So you're going to have to input those here. Again, we already did this for you for this part. And you'll notice that here you have to do output files, but in this cmakelist.txt, you didn't have to put any output files. You'll notice that this is all input files. Again, all of this information about the cmakelist.txt and the build.yaml file, these are in the README at the very bottom of the assignment. So right here, input and output files, as you begin using input files, yada, yada, yada. So just remember to look at this. Again, like this README exists so that you have documentation for the project, and we are trying to make this as easy on you as possible. So the last thing that you need to do in order to run this program successfully is that you need to let CLion know the different program arguments you're using. So C++ knows about it, the build.yaml file is telling GitHub Actions about it. So what you need to do is you need to come here and you want to edit configurations. So that's why if you don't have a configuration, that's a problem. So you're going to go to here and you're going to look at program arguments. And so program arguments, you're going to put input01.txt, and then if you have another input file, you would put input02.txt, or you would put output01.txt. So input files always go first, if that's how you've set it up, and then output files go last. That's how we traditionally do it. You may switch it around, but this is how we traditionally do it during class. So you're going to press OK, which applies the changes. And so now watch carefully at this terminal and with the output that you get. So now you can see that we get 10 through 90 as the numbers. And if you look at input01.txt, it's exactly 10 through 90. All right. So great, all that's great. Let's move on to the last part of this, which is going to be git commands. So in addition to git clone, there are 3 really important git commands that you need to know. They're going to be git add, git commit, and git push. And so those are ones for essentially saving your work and uploading it to the cloud where we can see it, right? Because we can't see anything on your local development environment until you push it up to the cloud where we can pull it down or we can see it. So let's do something simple. So instead of the average stuff, let's just print out something else. std cout. This is a tutorial, right? Because it is. So we're going to do that, right? We're going to control save, and we're going to run again. So you can also run it from down here as well. So running it, pressing the green play button will actually build it as well as run it. So it'll catch compile time errors first and then runtime errors. So now you can see that it does what we want to do. It prints out this is a tutorial, and it does all this other stuff as well. So let's say I'm done with this program. I don't want to do anything else with it. So I'm going to come over here. I'm going to go back to my terminal, and this is in the repository, in the correct repository that I didn't change anything from when I was in the terminal earlier. This is my project directory. So you're in your project directory. What we want to do is we want to do git status. So this is actually something that I use all the time to check like where I am in the git process. So you can see that I've modified main.cpp by adding that cout statement, and it says changes not staged for commit. So git add, I typically do git add all, but you can also do git add dot, and there's some other ones as well. You need to add changes to your commit by using git add, right? So I'm going to add that. Let's see how my git status has changed. Now it's green, which means I've added those changes to the commit, but I have not actually committed. Like I said in class, a commit is like a checkpoint, a bookmark. There's actually like a timestamp that is associated with it. So, but I'm done, right? So I'm going to do git commit. You're going to do -m for a message, and then you're going to do quotation marks, and I'm going to say added tutorial cout statement, right? Make sure these are meaningful. I'm going to press enter, right? And now it says I changed one file and I made one insertion, which is true. I added a line, right? And now we're going to do git status again. And it says your branch is ahead of origin master by one commit. Don't really worry about branches or origin master or anything like that. Just know origin master is like what is currently like what you're on, and origin is basically the well, I'll let you guys read about it in case I say something wrong. But basically, what you're going to do next is you're going to publish your local commits by doing git push. So you can do git push. Sometimes you have to specify origin master, especially if you are a Git guru and you have a lot of different origin targets or like different branches. So master, for example, is the name of the branch that we're currently on. This is what you're going to be on for most of your assignments. There's really no need for other branches, I think, at this point. You may need it for like your final search engine project, but it's not a big deal. I just get in the habit of doing git push origin master, because then there's no way that git push can push your changes to anywhere else. So you're going to press enter, and as soon as you see this master to master and resolving delta is completed with two local objects, blah, 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 or 100% here, as long as it doesn't show up with any like red glaring error, it's succeeded. So let's go back to our repository, and you'll see that this commit is the initial commit made by Dr. Fontenot. So we're going to refresh the page, and you can see that it was fetching the last commit, and this is me, hi, and I said added tutorial cout statement, and now there's two commits. I committed it 2 minutes ago, and this is when I originally created the repository 9 hours ago during lab. All right, so that is it, I think, for this tutorial. Just make sure, I know this was a little bit longer than I meant it to be, but make sure that you are, if you have any questions, please Slack me. This is pretty comprehensive, and it covers some things that I didn't cover in class, because I kind of left y'all to like figure out everything yourself and like do it step by step. But I really, a lot of y'all were kind of confused by the end, so I wanted to make this video to kind of clarify some things and really provide y'all with a comprehensive video that covered everything that we were going to do in class today, in case anything that we said as TAs were unclear. So again, shpeng@smu.edu is my email, or just Slack me. I'd be happy to answer any questions you guys might have. All right, signing off. Thanks.